Okay, welcome to another Orbiter 2010 video. I'm going to redo this live simulation launch with the March 1st, 2013 SpaceX flight. And this time I'm going to let the Autopilot fly the SpaceX Falcon 9 because I want to see how it compares with the real-world flight. I suppose it's possible and even likely that when I'm flying it manually, I'm just doing such a poor job that I'm getting really far ahead, but I don't think that's going to be entirely the case. I think you're going to find out here with the Autopilot that it's just as far ahead, if not, or very close to it, as I was flying manually. So we're going to warp time forward here. Again, we're going to get to about 310 seconds when we actually do the launch. I'll try to get everything exactly as close to the same as it was before, so that everything matches up identically. Okay, I know the video starts at here, so let me start the video.
All tanks at pressure.
And I'll change the time using...
T-minus 20.
Okay, 20, that's fine.
T-minus 15. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Autopilot's active.
Now liftoff of the Falcon 9.
Dragon ascends first stage acceleration.
Falcon 9 has cleared the tower.
Falcon 9 has indeed cleared the tower. The advantage here also of using the autopilot is that we can kind of look at the external view in orbiter.
Starting gravity turn. First
Terminal
stage
count launch is
full power.
complete.
So let's hear their
Stand
first
by.
call out. Their first call out is when they're at 200 and some odd meters a second. Switch the color. There we go.
Power
Now,
systems nominal, and we have a good telemetry lock on stage 1 and 2.
look at the velocity in orbiter.
First stage propellant utilization active.
And remember, their first call out's not till 200 and some
Vehicle
meters.
is 6 kilometers in altitude, velocity of 241 meters per second, and downrange distance of 1 kilometer.
Yeah, the add-on in orbiter is just way inaccurate because I was also very high.
Vehicle is supersonic.
And don't get me wrong, it's a great add-on, and I appreciate all the work that the developers did to make it. I don't mean to take anything away from them
Vehicle has reached maximum aerodynamic pressure.
by any means. The space shuttle is a little bit off as well, but this is a lot farther off than the space shuttle.
Second stage has started engine chill.
And remember, this is all autopilot. I'm not doing any control here. I'm just F1 back and forth between the internal and external. Shutdown of 2 engines. So we should have lost a little bit of thrust, I
Vehicle
believe.
remains on a nominal trajectory. Vehicle is 30 kilometers in altitude, velocity of 1 kilometer per second, and downrange distance of 23 kilometers.
Relative inclination's not going to be very good because we're already...
Dragon power systems normal.
Time to node's already increasing. So we're at MECO stage 1.
Vehicle remains on a nominal trajectory. Vehicle is 51 kilometers in altitude, velocity of 1.8 kilometers per second, and downrange distance of 59 kilometers.
See, they're half the speed we are.
Approaching MECO 1.
I didn't hear what their altitude was.
MECO 1. Past in MECO.
Flight computers in second stage.
Dragon ascends MECO.
MECO 2, stage 1 shutdown.
Stage separation confirmed.
Yeah, this is way ahead.
MVAC ignition confirmed.
AOS wallops.
And we're not talking about a second or two, we're talking what is that, a full minute?
Nose cone separation.
I'm not going to bother doing
All
that.
stations, MD on mission A, please proceed to procedure 7.101, Dragon on-orbit activation deployment. Standing by for Dragon separation and prop priming.
Second stage propulsion systems nominal.
The autopilot
Vehicle
doesn't...
remains on a nominal trajectory. Vehicle is 148 kilometers in altitude, velocity of 3.2 kilometers per second, and downrange distance of 346 kilometers.
So we're about the same altitude. So the autopilot definitely did a better job on the ascent than I did.
Second stage propellant utilization active.
It's pitching up because it can sense that the vertical speed's getting too close to zero. Now its vertical acceleration is almost, it's over zero now, so it's climbing. See, time to apoapsis is increasing. So it's interesting that even the autopilot makes that type of maneuver. It doesn't have it calculated so well that it doesn't have to adjust pitch during the flight. That's interesting to note for me. Because I kind of almost feel like, you know, once you start the gravity turn, it should be continuous and you should never have to pitch back up. But
Vehicle remains on a nominal trajectory. Vehicle is 182 kilometers in altitude, velocity of 4 kilometers per second, and downrange distance of 541 kilometers.
see, its altitude's 182, so it's above us, but we're faster. You know, it's just interesting. I'd be really curious when I get up to orbital velocity, which is only going to be another 2,000 meters a second, just how far off in time will be between the recorded flight. Take a look at the aligned plane MFD, I'm curious.
Second stage propulsion systems look good.
Its relative inclination is counting down, but it's
Power
going.
systems look nominal, and we have a good telemetry lock on stage 2.
It's only going to get so good though because the time to the node's increasing, so it can't get to zero. I hate this chair. It squeaks and cracks every time I move.
Vehicle is 200 kilometers in altitude, velocity of 4.6 kilometers per second, and downrange distance of 767 kilometers.
I have no idea what my downrange is. I guess if I targeted KSC, I could get that information. 1,000 kilometers. I forgot what they said their downrange was. Coming up on orbital velocity. Apoapsis increasing. I think I set it for 330. Okay, so we got MECO at 7 minutes 10 seconds according to the recorded video playback. And it's not going to reach that for like another 80 seconds. So we were 7:10, and I think the video gets to like 8:30 or 8:40 before it cuts out. So that's the difference.
Vehicle remains on a nominal trajectory. Vehicle is 210 kilometers in altitude, velocity of 5.6 kilometers per second, and downrange distance of 1,080 kilometers. IMU and GPS look good.
So the total relative inclination difference for the autopilot was 0.23, but that's not
Vehicle is passing through the head-on gate.
entirely the autopilot's fault because it depends. I may not have launched at the most ideal time for the autopilot, but I knew it wouldn't get to zero
Stage 2
because
propulsion systems continue to be nominal.
the time to the node was increasing. And orbiter crashed. Well, that sucks. But they're coming up on MECO here in just a moment anyway. again, it was 7:10 according to the video playback time when
Vehicles and terminal guidance.
I hit MECO. So now we're 80 seconds past.
FTS is saved.
90 seconds. So that's a minute and a half. That's a big difference. A minute 40. One minute 50 seconds. So the SpaceX in order is like 2 minutes ahead.
LO escape.
There's 2 minutes. Two minutes 10 seconds. It's even more.
MX shutdown
Flight
confirmed.
computers in separation state.
There you have it. 2 minutes 10 seconds. That's a pretty big
Dragon
difference.
has
Vehicles.
sensed Seco.
Vehicles orbital.
All right, I'm gonna go ahead and stop the
Parakeet.
video. I got the information I wanted to know, and clicked on the wrong thing. If you like the video, please do hit the like button and subscribe to the channel. And just let me know what your thoughts are on this whole thing. If you've flown the SpaceX module, what kind of results have you had? Have you ever tried to compare it with the real flight? And leave some comments down below. Let me know what you think. See you in the next video. That when I'm flying it manually, I'm just doing such a poor job that I'm getting really far ahead. But I don't think that's going to be entirely the case. I think you're going to find out here with the autopilot that it's just as far ahead, if not, or very close to it, as I was flying manually. So we're going to warp time forward here. Again, we're going to get to about 310 seconds when we actually... Okay, welcome to another Orbiter 2010 video. I'm going to redo this live simulation launch with the March 1st, 2013 SpaceX flight. And this time I'm going to let the autopilot fly the SpaceX Falcon 9 because I want to see how it compares with the real world flight. I suppose it's possible and even likely.
T-minus 15. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Autopilot's active.
Flight computers in
Now liftoff of the Falcon 9.
Dragon has sensed first stage acceleration.
Falcon 9 has cleared the tower.
Falcon 9 has indeed cleared the tower. The advantage here also of using the autopilot is that we can kind of look at the external view in orbiter.
Starting gravity turn.
As we do the launch, I'll try to get everything exactly as close to the same as it was before, so that everything matches up identically. Okay, I know the video starts at here, so let me start the video.
All tanks at pressure.
And I'll change the time using...
T-minus 20.
Okay, 20, that's fine.